Hello everyone, welcome to my channel. Today we are solving find minimum in rotated sorted array 2. So we are given an array of integer that is sorted but is also rotated fixed amount of times, and we are going to find the smallest number and return the smallest number. And it also contains duplicates, which is different from the find minimum in rotated sorted array 1. So for example, we have this array that is sorted, and the original array was in a non-decreasing order. And if you rotate it, in this case 1, 2, 3 times, rotate each element 3 times, and we have this array that is given. And we're going to find the smallest number and return the number. So we're going to solve this using binary search. So we are going to have a left pointer starting from index 0 and the right pointer starting from the end of the array. And every time we're going to have a midpoint. And what we are going to do is we are going to compare the value at the midpoint and the value at the right point. So if the value at the midpoint is greater than the value at the right point, then we're trying to find the smallest number, so m cannot be the smallest number. So we're going to shrink the binary search. Since it's in non-decreasing order, we can ignore this part. We can ignore the left side of the midpoint. So we can move the left pointer to m plus 1. So in this case, we can move the left pointer. And another condition we have is if the midpoint is less than the right point. So in that case, right point cannot be the smallest number, so we can move that, and it will be at the midpoint, since midpoint could be the smallest number in this case. Let's check this another example. And we might have duplicates in the array, so we might have the same number for the m and the r, which we do in this example. So in that case, r, we can either lose m or r since they're the same number, and 2 can be the smallest number, but we only need 1. So in that case, we are going to move the right pointer, and we're going to decrement it just by 1. So we're going to do this when the value at the right point and the midpoint are the same. So this moves here, and let's do the next operation. Value at the midpoint is greater than the value at the right point, so we're going to move the left pointer to midpoint plus 1, and then midpoint will be here. We can break out of the loop when the left and the right pointer are right next to each other, and we can just return the smaller value, in this case 0. So that is basically it. Let's write up the solution. So we're going to do a binary search. So we're going to have some pointers. We can have left pointer starting from index 0, and the right pointer starting from the end of the array, so length minus 1. We can have a while loop, and we can break out of the while loop when the left and the right pointer right next to each other, so left plus 1 is less than right. So we're going to calculate the midpoint every time, so that's going to be left plus right minus left divided by 2. Some people do something like left plus right divided by 2, but left plus right can cause integer overflow, so we want to avoid that. So we can use this instead. And we're going to have some conditions. We're going to compare the value at the midpoint and the right point. So if the number at the midpoint is greater than the number at the right point. In that case, we are going to move the left pointer. So we can do left assign mid plus 1, since the midpoint cannot be the smallest number. And we are also going to have, if the number at the midpoint is less than number at the right point, in that case we're going to move the right pointer. So right assign mid, so the right pointer will move to the midpoint. And otherwise, the midpoint and the right point, the value there will be the same. So in that case, we're going to move the right pointer, since we only need one of them. So right decrement. And at the end of this while loop, the left and the right pointer will be next to each other. So we can just return whichever one is smaller, since we're trying to find the minimum number. So we can do return, we can check if the number at the left pointer is less than the number at the right pointer. In that case, we're going to return the number at the left pointer, and otherwise we're going to return the number at the right point. Alright, so that is basically it. Let's check if this works. Okay, so this was find minimum in rotated sorted array 2. Thanks for watching.